Okay guys, today in this video we will learn about BPSK, that is the binary phase shift keying. So first of all, we must know that what is meant by the word binary. So the word binary means two, that is 0 and 1. Actually, in digital electronics or in digital communication, 0 and 1 are the two logic levels. You can also assume that if current flown is shown by 1, then current stop will be represented by this 0. Or you can also consider that if this 1 shows us the bulb on, then 0 will shows us the bulb is in off state. So actually 0 and 1 are just the logic levels. You can also assume that 1 is 5 volt and 0 is actually ground. So these are actually two states. So then we will come towards the digital signal, that is comprised of 0 and 1. You can see that it consists of 0, then sudden rise, and then 1 and 0, and 1 0 1 1 0. So digital signal is always in this form. Then we will come towards the constellation diagram. So in this constellation diagram, we will make two axes, then and we know that in one axis there are 180 degrees. This is the line of 0 degree, then it will rotate and it will end at 180 degree. So we will assume that on 0 degree, or 0 degree will tell us about, or 0 degree will be considered as 0 and 180 degree will be considered as 1. So here we have one sample signal. And actually what's the meaning of this sample signal? It starts from this 0, and upon the course of time, that is as the time goes on, like on x-axis, the x-axis proceeding is actually the time, and y-axis is showing the amplitude or magnitude. So this sample signal, as we know that it is a sinusoidal signal, so it starts from 0, it will gradually increase, and from the summit it decreased down to 180 degree, and it is the half signal. From 0 to 180 degree is half signal. Then from 180 degree to 360 degree is actually the next part of the signal. So half and half signal is actually the full signal. From 0 to 360 it is the full signal. Then we know that our information signal, or the signal, digital signal, which has some sort of information, is actually consist of 1 0 1, or like in any combination it can be like 1 1 0 0 0 1 or 1 0 1, so on. So what will happen actually when there is 1? When there is 1, our sample signal will start from 180 like this, and will go to this point. Like we have to complete the signal. Like as we know that in constellation diagram, 180 degree denotes 1. So when there is 1, then our signal will start from 180, but it will complete its cycle, and one cycle consists of one trough and one crust, one negative side and one positive side. So here you can see that we actually starts from 180, 180, and then ends at here. So for 0, as 0 in this signal, we can say that 0 corresponds to 0. 0 degree corresponds to 0, or 0 corresponds to 0 degree. So here 0, 0 will be start from this 0, and it will go to 180 and then follow this course. So it is like this. So for 0 it is like starting from 0 and go above, and 180 and then 360. Then again there is 1. So in this part, for 1 we know that we will start from 180, 180, and then here, and then it high, and then it will end at this point. Okay, but we know that there are actually two main things. One is the carrier signal, and the other one is actually what? The other one is information signal. So binary phase shift keying is actually some sort of modulation technique in which carrier signal is usually of sine format, or it's having the sinusoidal form. And then what will happen? These information, or the data signal, or any signal which is having some sort of information, it will treat, or it will deal with carrier signal like this. So carrier signal, after combining with that of information signal, is not just like this one, but like this one after combination. So now we will come towards the mathematical equations for BPSK. So here we will learn that the phase of the carrier wave is modulated by the binary symbols, that is 0 and 1. Phase here, as we know that phase means the angle theta, but in real world phase corresponds to the time, because every quantity needs time to increase or decrease. So the phase of the carrier wave is modulated by the binary symbol, that is 0 and 1. Yeah, we know that, because if there is 1, the phase of the sinusoidal waveform will change, is according to the 0 and 1. So carrier wave is usually a sinusoidal wave of high frequency. Yeah, we know that in every modulation technique, usually the carrier wave is of high frequency as compared to that of theta, or the wave which is having some sort of information. This is obvious, like FM or anything like that. The communication signal consists of zeros and ones, that is of digital waveform. Yes, we know that carrier signal is in the form of analog, but communication signal consists of zeros and ones. Zeros and ones means the logic levels like 1, 0, 1 and all this. Okay. Then we are going towards the mathematical equations or mathematical model of the carrier wave. We know that S of t is equal to a cos of 2 pi fct. But actually, what is the hidden thing inside this equation? We know that when there is a thing written as S of t actually means an instantaneous point. where there is s of t, if t is a single single letter, like a single integer like 1, 2, 3, 4, then s of t will be the instantaneous thing. Like you can say that if t is equal to 1, then actually s of t is equal to s of 1. So it is instantaneous. But if t is like 1, 2, 3, 4 and in the vector form, then we can say that now after having so much integer as an input or array of integers, we cannot say that it is an instantaneous value, but it is like a full waveform. So here, and we know that where there is a wave, there is amplitude or magnitude, and if magnitude is 0, we can say that no wave is there. So a cos of 2 pi fct means there is amplitude, then there is cos. Cos is what? Actually cos and sine, these both functions will gives us the sinusoid. These cos and sine gives us the sinusoidal signals. And what this actually, the whole thing in the bracket is actually theta. So what is theta? So theta is equal to 2 pi fct. You know why there is 2 pi? 2 pi is actually, you can say that 180 or half signal. 2 pi is actually what? Is a full signal. Means 0 to 360. Then we will come towards FCT. FCT means carrier frequency. Obviously carrier frequency of different signals or different modulated signals can be different. It can be less, it can be some bit high. So you can assign the value of carrier frequency. Then T is actually the same in S of T. So it is T. Here A is the peak amplitude of the sinusoidal wave. Yeah, you can say that A is the peak amplitude of the sinusoidal wave. The difference between magnitude and amplitude is that amplitude is the maximum magnitude possible within a phenomenon. Like if it is a pendulum or mass attached with spring or these modulation techniques and in digital electronics. Amplitude is actually the peak amplitude of the sinusoidal wave. So it is the maximum possible magnitude. Then we will consider 1 ohm load resistor. Then power dissipation is given as 1 ohm is actually a standard load resistor, and we know that where there is a resistor, there must be power dissipation if some sort of power is given to the resistor. We can only get the power dissipation if we have some sort of resistance or some element resistor. So power dissipation is given by power is equal to V square RMS divided by R. So why there is V square RMS by R? Because we know that sinusoid has two main halves. Like first half is actually this positive half, and the next half is actually the negative half. So if we used to take average, then if it is plus 180, it is minus 180 or anything like that, it will be equal to 0. But in actual world, it cannot be equal to 0, because power is related with that of energy. So there is law of conservation of energy. So we used to take, rather than taking this simple what's called as average formula, we will actually introduce the concept of V square RMS, that is root mean square. And why we will take this root mean square is also some bit logical, that we know that in real world there isn't anything as negative. Either it can be 0 or either it can be positive. Yeah, and it is the fact there. And when there is under root applied, one cannot introduce minus in this. It must be 0 or 2 or 1 or anything like that. Why it is so? Because in real and physical world nothing is going to be minus really. However, some in theoretical concept we can introduce some iota or minus under root minus 1 or these things, but actually in real world we cannot say all this. So we will introduce the concept of v square RMS by r, and we know that where there is v square RMS by r, it is equal to v max divided by under root 2, and it is whole square. Because why there is square? Because if you are introducing under root in any equation, you must have to introduce a square in order to counterbalance both the things. So here we know that v max divided by under root 2 is actually equal to this, because we have introduced r is equal to 1. So here r is equal to 1, and here amplitude v max is actually voltage maximum, and its amplitude is a, and after applying square it is a square divided by under root 2, but square cancel with that of this, and then a square divided by 2. So this is your final answer for power dissipation. So here you can see that power is equal to a square by t, a is equal to amplitude is equal to under root 2 into power. Again, then when there is a change from 0 to 1 or from 1 to 0, then there must be a change of 180 degree or 180 degree phase shift, changing from 1 to 0. Yeah, we know that when it is when our digital or what's called as the data signal or communication signal is going from 0 to 1 or 1 to 0, then we can see that there is a phase shift of 180 degree. So we can say that if we have one symbol s of t is equal to under root 2p cos of, because we know that here under root 2p is actually equal to the amplitude a. So we can see that under root 2p cos of 2 pi fct, where fc is carrier frequency. Then for next signal 0 we have, because we know that when it is for if this is for 1, then if one is going from 1 to 0, then what will happen? This thing will happen, that pi must be added to this symbol. Why it is so? Because we know that it's going from 1 to 0, or there is a symbol change. So then under root 2p cos of 2 pi fct plus pi, and we know that cos of pi plus theta, because this whole thing is actually what? Theta. So theta plus pi is equal to minus cos of theta, or minus 2 pi fct. So you can introduce minus in the start. So now we have to combine these two equations. Then S2 of t is equal to minus under root 2p cos of 2 pi fct. Then we can say that BPSK will be like that signal. That is S of t is equal to B of t under root 2p cos of 2 pi fct, where B of t is actually what? It is actually an instantaneous value, and it can be plus 1 if 1 is being transmitted, and it is minus 1 if 0 is being transmitted. As we know that digital signal comprises of 1 and 0. So either 1 is being transferred or 0 is being transferred. So it's all about BPSK. Hopefully you got some sort of concepts. Thanks for watching.